Yes. Oh, we don't understand the question yet. Okay. Okay. So, I have 100 cards, right? I have 100 cards. I feed 2 cards to the machine. 1 comes out. Now what do I have? 99 cards. Now, I have 100 cards. I feed 2 to the machine, and yeah, a new card comes out. It chews up the 2 old cards and recycles them, and out comes a new card with a new number on it. Yeah.
But then we don't throw away anything, right?
Never? Now you have 99 cards. Yeah.
So you don't throw away.
You use 2, you get 1. Now you have 99. You use 2.
100 cards, a number from 1 to 100.
Yes. You use 2 of them, you get 1. Now you have 99 cards. Maybe you have 2 62s now.
The outcome
Yeah.
be among one of those cards.
Yeah, would be another card. It could have some number that's not 1 through 100 anymore, right? Right? Some big number on it.
1 and 2 of them will produce up to the number, but the order's done, right? So, like if you get a bigger number, like 60 or above, then
We're going to get some huge number out, yeah.
that's possible.
Yeah.
That's cool. Okay. All right. I see. All right.
Oh, good. That's the first step, for sure.
Cool. Now, did you want us to assign jobs? Is that what you wanted us to do, or can we just dive in?
I want everybody to dive in and find ways of supporting each other without spoiling anybody's fun of discovery. That's really, to me, the key. You want everybody to have that joy of discovery and not have somebody who's racing ahead saying, hey, look at this, hey, look at that, hey, look at the other thing, right?
Sounds good.
Yeah.
I want to make it simple.
Work your way to the middle. Somebody starts with consecutive.
This is another card?
Yes.
Is that allowed there?
I don't know. That's our new card. So our numbers go 1 to 98, and then 10,099. And then you put.
So that way, then we have infinite many outcomes. So this process never terminates. So,
Yeah, we get rid of cards.
We get
Every time we're going to get rid of 1 card.
Yes.
We put, like, say we did 99, 98, 100 right away.
Okay.
We get 10,099. Is that a
guess.
card, a 10,099 card?
Yeah.
We can put that with...
Sure. With 17. Put that with 17 next. And see what happens.
Then we can do 97, 96. Put those 2 cards in.
Sure. Whatever you want. Any 2 cards. Whatever you want to do. There's lots of choices.
That's...
Oh, so that
It gets really high, then they're real large.
She's going to tell you what comes out. They can just pick 1 or 2.
Okay. Very good. Just remember that.
Order question before doing that.
I don't follow.
Well, so if we had a list of 100 numbers and we were just going to take 2, multiply them, and then take the next input, multiply, and so on, like the way we would explain to ourselves that the order doesn't matter is that multiplication is commuted in that system. I'm not talking too abstractly
And looking at it consecutively, you have your multiples and you're adding 4. The change is 4 each time.
So it's linear?
No, it's not. No.
So what do you mean?
It's like it's just like this right here is 1 times 2 plus 3 plus, and then it's 3 times.
Oh, what you're
4.
adding is
increasing by 4. But that's if we use consecutive. I've just noticed it's not. I'm not sure.
Leading us to the solution, it sounds like.
I don't think so. Not really. I don't think so. At least this didn't help me get the solution. It's just, but it helps kind of narrow your thinking to not worry about order. That's what I think.
Right.
But right now, with this, we got rid of cards 99, 900s are gone, 98, 97 are gone. That we have left. So now we can do 95 times 96, get that answer. And I would think you'd do like 93 times 94, get that answer, multiply those together, and then take that times this card. You know what I'm saying?
So do 98 times 10,099. Do you have a calculator? You do 98 times 1099. All right, we can jump
I
in.
mean, but all we showed is that the order doesn't matter. Right.
Okay, so
When we pick three numbers. Right.
yeah.
But the three numbers that we pick matter, right?
Yeah. Yeah, I mean, if you did 2, 3, and 4, it would do a
Doesn't
different.
tell us anything about our input.
We can run them through again.
You got one.
But if we did,
So now, all right. So now we're going to try and figure out what the output is if we know the input. And what you're saying is we should pair up the beginning and end to see if that helps. All right. So maybe we should do that with a small example too.
That's when you put them in.
So 1 to 4.
1 to 4 sounds good to me.
So you have a good strategy here of using an easier problem, but you're not really being ambitious enough in your use of that strategy. You're doing like the beginner level easier problem. So it would be a higher level easier problem you could
What
do.
we're wanting to do here, though, is not just do an easier problem, but we're trying to come up with a strategy that's in terms of, would it help us to start small with large, or would it be better to look just consecutively?
Right, but wouldn't you get the answer to that question a lot faster if you tried 1, 2, 3, 4 instead? Because you could still do even and odd, or consecutive, or pairing from the outside in, and you'd have your answers for all these different methods in almost no time then. If you did 1 through 4 instead of 1 through 10.
Yeah.
Right, and so that the more expert the problem solver, the easier the problem they do, is what I tend to observe. So when you have 1 through 10, you're going to labor through a lot of calculations, and then you're going to have to think, well, what's different about this one, and was there an arithmetic mistake here, and all this stuff. And if you do an easier problem, you get boom, 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 a bunch of results really quickly that you can look at to try to figure out what's going on.
By ambitious enough, I thought the opposite. I thought you meant we needed to take bigger than 10.
Right. No, so and same with wishful thinking, right? I mean, some people will think that switching to A and C, oh, come on, this is silly. It's not even a problem anymore. But it leads to some insight to do the super easy thing to begin with. Then you've got something you can do, and then it's done, and it's hardly cost you any time. So if it gives you even a little bit of benefit, it's really worthwhile to do the super easy problem to start with.
The order doesn't matter.
Are you sure?
No.
Our conjecture.
Good.
33. Sorry. Are you doing that right? No, that's 4 times 2. No, that's right. 4 times 2 and 3 times 2. Yeah. That's the largest we could get if we did 1, 2, 3, 4.
We just ran them through.
Wow. Okay, so explain. I don't understand what you're doing to get 299, because that seems really big to me.
Okay. So we took the answer when we did 4 and 2, and 3 and 4. Okay. One answer was 4.
But you used 2 4s then.
No.
Oh, yeah, we did.
You used 1 in your 4 and 2, and 1 in your 4 and 3.
2 and 1. Okay. Got it. Okay. So really that's too big.
You can also play with different rules where you have multiple copies of a bunch of cards and explore. I mean, this question is about what happens if you start with 1 each of 1 through 100, but along the way there you might run into all kinds of other questions, like what happens if you have unlimited supplies of cards, or I don't know what. I mean, those are all good questions.
Lots of big numbers. Okay, thank you.
Yep.
Right, so now what do we have? So the 5 and
19 and 19.
but we're only working with 1 through 4. All right, so we're working with 1 through 4. We now have 1 card left, which is 119.
So then I guess, right, this is a bit of a
what you're gonna get
issue here, because then we're going to have to start combining these numbers.
Every time you do it,
Why?
What are your 3 numbers in your beginning?
So, have you considered our strategies here?
That's why I'm the smaller number right now.
Okay, but remember, like with the ABC thing, we switched the A and C. That made the problem really easier, right? You want to go as far down the scale as you can toward
1 and 2.
yes, or just 1. Well, the question is, when you get down to one card, what do you have? So if you start with one card, you've already gotten down to one card, and what you have is one card with number 1. That's pretty quick to understand, and you're done, right?
Go through that again.
The question is, when you get this whole pile of cards down to one card, what numbers are possible for that final card? If you start with one card with number 1 on it, then you also end with one card with number 1 on it, and that's it. There's no other possibilities. What you end up with is what you started with, and that's it.
The question is, what's the largest output? We're supposed to be answering that?
Yeah, what's the largest output?
With one card.
But with one card with number 1 on it, all that you get in the end is one card with number 1 on it, because you can't use the machine any times.
Because you need 2 cards to use the machine. Is that what you're saying?
Yeah.
Yes.
Yeah.
So
if you start with a 1 and a 2 card, now things get a little more interesting. All right, I'm going to interrupt in about a minute, so try to kind of wrap up what you're in the middle of at the current moment, and then... you guys are fast. That's good. So now you have some other interesting questions, like what outputs, like if you had a collection of all the positive integers, what outputs are possible and what outputs are impossible? That's a good question. There's lots more questions.